Alright, so today we're going to be talking about speed and average speed and velocity. And so let's get into it, shall we? So just to go over a quick agenda, it's going to take us less than a minute to do this, the agenda part. And then we're going to spend about 10 minutes on some reading and guided notes. And then we're going to do about 15 minutes worth of sample problems together to make sure you're on the right track. And then you'll have time to complete the independent practice on your own, which should be about 15 minutes of work for you, give or take, depending on if you like math or not, I guess. If you don't like math, maybe it'll take you a little bit longer. But right now, you should have open your worksheet from this lesson. And we are going to look at finding erasers. We're going to look at some notes, and I'll fill in these blanks as we go. So you could find eraser speed at any given point. We've got some erasers here in the picture, but we can find their speed at any given point in time just by measuring the distance that they travel, and we want to measure the distance that they travel in short little increments. So time intervals would be anything from years to months, days, hours, minutes, seconds, milliseconds, nanoseconds, basically anything that keeps track of time. So instantaneous speed is taking measurements of the distance traveled in short intervals and tracking the amount of time that it takes for the object to cover that distance. So the shorter the time interval means the more accurate your measurement of speed would be. So the higher the accuracy, the more instantaneous the speed is. So when you use extremely short time intervals to measure the distance, it calculates an extremely accurate measurement of speed. And so this is what we call instantaneous speed. So I want you to take a few minutes, pause the video here, answer the two questions that are on your worksheet based on what we just learned, and they're found on your worksheet on page 1 under the subtitle You Do. So pause it here. When you're finished answering those questions, you can start the video again. Alright, so instantaneous speed, by definition, is the speed that we measure at any given point in time. So if you think about a car's speedometer, it's essentially measuring instantaneous speed, because each little click of the cable or the digital dial or whatever sensor they're using is measuring the amount of time it takes to travel that amount of distance. So let's talk a little bit about velocity, because it isn't exactly the same as speed. In fact, the thing that sets velocity apart from speed is that when you use velocity to describe motion, you have to also include the direction of that movement, that motion. So direction can be either your north, south, east, west type of directions, or it can be toward a fixed point, something that's not ever going to move, like a building or a road or a sign, something along those lines. So when you're calculating velocity, you want to make sure that we always include direction, and if the object moves in multiple different directions, you can use the final direction in your answer, or you can look at the general direction based on the displacement, which you should recall is the straight line measured between the start point and the stopping point of the object in motion. So if you draw a line from the start point to the stopping point, the direction that points would be a direction that you could use in your answer. Alright, so there's a video for you to listen to. So watch the video. You'll learn a little story about a little lion, very big lion actually. That was kind of a scary thing that happened once, probably more than once. Maybe even the reason that Madagascar got made into a movie. Anyway, listen to the video, and then you'll be able to answer the next set of You Do questions.
Velocity describes both speed and direction. Sometimes describing the speed of an object just isn't enough. You may also need to know the direction in which the object is moving. For instance, in 1979, a 450-pound lion escaped from a zoo in Florida. The lion was located by searchers in a helicopter. So the helicopter crew was able to guide the searchers on the ground by reporting the lion's velocity, which is its speed, and the direction of its motion. The escaped lion's velocity may have been reported at 4.5 meters per second to the north, or to 2 kilometers per hour toward the highway. Without knowing the direction of the lion's motion, though, it would have been impossible to predict the lion's position. The direction of motion can be described in various ways, such as east, west, south, or north of a fixed position, or it can be an angle from a fixed line. Also, direction can be described as positive or negative along that line of motion. So if a body is moving in one direction, it has a positive velocity. If it is moving in the opposite direction, it has a negative velocity. In this book, velocity is considered to be positive in the direction of the motion.
Okay, so what was the lion's speed? Okay, so remember, the velocity formula is the same formula that we've been using with speed, and it's volume divided by, or volume equals distance divided by time. So we can rearrange our formula so that we can solve for distance and time. So we might not be given the distance, so we might have to solve for distance, but we would be given in that case the velocity and the time. So to solve for distance, it would be distance equals velocity times time. Or if we needed to find the time because we weren't given that, but we were given the distance and the velocity, then we would take distance divided by velocity to find the time. So we can find any of the three variables based on what two variables were given, and that allows us to find the third. So using the formulas on your worksheet, complete the 12 problems below. You're going to finish these problems on your worksheet and submit it in this lesson.